Hi.
Hi, how are you?
I'm good. How are you?
Good. So I'm fine. So you're Siksha, right?
Yep.
Okay, good. So shall we start? Are you able to see me properly?
Yeah, I can.
Okay, and my voice is also audible to you,
Hmm?
right?
Yeah, I can hear you.
Okay, good. So we can start with our topic. Let me clear all the previous one first, because usually we don't take two students in one class. So let me clear this all so that we can start with the new thing. Okay, now today's topic is, do you know today's topic?
No.
It is ratio. Okay. No, have you heard the term ratio before?
Yeah.
Okay. Do you know anything about that?
Um, I don't really know anything about it.
Okay, it's fine. It's fine. Okay. Now, ratio is actually used to compare quantities. Okay. So let me write it for you. It is used to compare two or more quantities. Right.
Yeah.
Okay. Let us understand how. So I'm going to share an image with you. Let me know when you're able to see it. Okay.
Okay.
You can also put the image in the center of your screen by scrolling on it, okay? You can scroll on your screen. Are you able to see it?
Yep, I can.
Okay, good. Now here you can see that the question is to find the ratio of squares to circles, right? Now we have 3 squares and we have 5 circles, okay? Now there are 3 ways to write it. You can either put a colon and you can call 3 ratio 5, okay? Or you can write it 3 to 5, or in the decimal form, fraction form, which is 3 by 5, okay? Now, the one important thing that we need to notice is because they have asked in the question to find the ratio of squares to circles, they have written squares first, right?
Yep.
So we are going to put the number of squares first everywhere, even in the numerator, okay? And here, because they have written circles later in the question, so we are going to put number of circles later everywhere, even in the denominator. Okay, so if they reverse the question to find the ratio of circles to squares, so the answer will get reversed. It will be 5 ratio 3, or 5 to 3, or 5 by 3. Okay, because they have asked for circles first, they have written circles first, so we are going to place the number of circles first everywhere, even in the numerator. Okay, and because they have written squares later, so we are going to place the number of squares later, even in the denominator. Okay, now we understood that there are 3 different ways to write it, right? Okay, now what is the physical meaning of ratio? Now if someone is going to ask about what is ratio, then you are not going to do all this math in front of the person, right?
Yeah.
You have to give something one word answer, right? So to give you exactly the physical meaning of ratios, the way we read it, that for every 3 squares we have 5 circles. This is how we read a ratio, that for every 3 squares we have 5 circles. Okay, let us take one more example. I'll share again an image with you. Let me know when you're able to see it. Are you able to?
Yeah.
Okay, good. Now here you can see that the question is to find the ratio of smiley faces to hearts using all the 3 methods. Now we have 4 smiley faces and we have 6 hearts. Now there are 3 possible ways that we can write it. We can write it either by putting a colon and we call it 4 ratio 6, or 4 to 6, or 4 by 6, right?
Mm-hmm.
Now, because they have asked to find the ratio of smiley faces to hearts, they have written smiley faces first. So we are going to place the number of smiley faces first everywhere. Okay? Even in the numerator. Okay? And because, are you able to listen to me?
Yeah.
Okay, good. And because they have written hearts later, so we are going to put the number of hearts later everywhere, even in the denominator. Okay? Now, what if they are going to reverse the question? And what if they ask to find the ratio of hearts to smiley faces? So, what we're going to do? We are going to reverse the ratio. The answer would be 6:4, or 6:4, or 6/4. Okay? So one thing which is important is that the order really matters. Here the order was smiley faces to hearts. Here the order has changed. It is hearts to smiley faces. So the answer has also changed. It is 4:6 here and it is 6:4 here. Right? So the order really matters. Okay, now let us again go to the physical meaning. What is the physical meaning for this question? That for every 4 smileys, we have 6 hearts. Okay, this is how we read a ratio. So we read it that for every 4 smileys, we have 6 hearts. Okay, now there's a assignment that I've made for you. You don't have to do it alone. I'll definitely do it with you. We'll see that if you're able to do those questions. Okay, let me share it with you. It's a very simple one. You will be able to do it very easily. Let me know when you're able to see it, okay?
Okay.
So, do you see it?
Yep, I can.
Okay, now here they're asking for ratios, okay? So you can answer the question and I can write it here, okay? I can also allow you to write, but you're using a phone, right? I don't know whether you will be able to write on the screen or not.
I have paper in front of me.
Okay, you can also tell me the answers. You can write on the paper and tell me the answers, okay? Now we have 4 tomatoes and we have 3 onions. So what is the ratio of tomato to onion?
The ratio of tomatoes to onions is 4:3.
Very good. This is 4:3. Okay. Now let us move to the next one. So we have 2 blue cups and we have 8 yellow glasses. So what is the ratio of blue cup to glasses?
2 to
Very good.
8.
Good. 2:8. Very good. Now this one, now here you have to really carefully see the order. So we have t-shirts and shirts. So what is the ratio of a shirt to t-shirt?
I can't really see it that well.
You have to scroll your screen, dear. Scroll the screen. Are you able to see it now?
Not really.
Why that's so? I'm scrolling it here. You have to scroll your screen there.
How much purple ones are there? I can't really see the purple ones.
Sorry, wait a second. Still not able to see it?
Oh, I can see it now.
Oh, good. Good, very good.
The ratio is 5:4.
Wait a second. Again, see the order. The ratio of a shirt to a t-shirt.
Oh,
See the order first.
4:5.
Good. Very good. This is what I'm telling you. The order really matters, okay? Otherwise, the answer is going to change. Okay? Let us see the next one. Do you see it?
Can you scroll it up a little bit more?
Up a little more. Okay. Yes, you can tell me. Yeah. Able to see it?
Wait, let me just move this.
Yeah.
I can't really scroll down on my screen anymore.
Actually, you're using a phone. Otherwise, it's there for a laptop or a PC. But it's fine. Let me scroll it for you again and let me know when you're able to see it. Okay? That is a 4th question. Are you able to see it now?
The screen isn't changing for me.
It should change actually. This is the first time it's happening that the screen is not changing for you. It usually happens.
Oh, now it is.
Oh, very good.
Okay.
So, count it.
It's 6:3.
Very good. 6:3 or 6:3. There are three possible ways you can write it either way. Okay, now this one. Be careful. Able to see it?
I can't really see it right now.
Again, scroll your screen. Or give it some time.
Shrishti, can you help me?
Place your cell phone on something, a stable thing.
Maybe I'll put it this way.
No, the screen will get rotated.
It's right now stuck on
On the previous question?
Yeah.
Actually, your screen will be controlled by you only. So, according to you, scrolling the screen, it should come.
Oh, now it did.
Okay, good.
The ratio is 3:2.
Is 3:2. Very good. So now you have answered all the questions. So do you know that in the previous one, in the fourth one, are you able to see the fourth one?
Yeah.
Okay, good. So do you know that we can also write 6:3 as 2:1? Do you know that?
Yeah.
Okay. Can you give me some explanation? Any short explanation? I'll explain it to you. Otherwise,
it's because 6 to 3 is also means 1/2, and 2 1.
Yes. Yes, very good. So let us think it another way. Okay, this is something very mathematical explanation, right? If you're going to tell to a kid, so he or she won't be able to understand that, right? So let us see one thing. So the way we read 6:3 is that we have 6 apples, say, okay, for every 3 bananas. Okay, this is how you say 6:3. So you have 6 apples for 3 bananas. Okay, this is how you read it. And what for 2:1? It is that for 2 apples you have 1 banana, right? Okay, now here if you see, you have 2 apples for 1 banana for 2:1, right? But if you see 6:3, here also you're following the same pattern. You have 2 apples for 1 banana each. Okay, here also 2 apples for 1 banana, and here also 2 apples for 1 banana, right? So the thing is that because they're following the same pattern, that is why you're able to write 6:3 as 2:1. Okay, now you understand it? So usually maths, what we think of maths is only a mathematical explanation. Usually a maths is something based on patterns. So here you see the pattern very clearly. The 3 of them are actually following the same pattern, which is followed by 2:1. Okay, let us see one more example based on that, so that we can confirm that yes, it follows the same thing. Let us take example of 2:4. Do you know how we can write it other way?
1:2.
Very good. You can write it 1:2. Good. So now here, the way you are going to read it is that for 2 apples, you have 4 bananas, right? Okay, and for 1:2, you can say that for 1 apple, you have 2 bananas, right? But the physical explanation is that for 1 apple, you have 2 bananas here, and for 2:4 also, you're following the exactly same pattern. You have 2 bananas for 1 apple, and for this one too. Okay, so you're actually following the same patterns in both the cases. That is why you're able to write 2:4 as 1:2. Okay, good. And what if I give you something like 8:10? What will be the answer for this one?
The answer will be
I'll give you some time.
Could it be 4:5?
Very good. This is 4:5. Okay, now the thing is that you're actually finding out the common factor here. Do you know what is a common factor?
I'm pretty sure.
You know common factor. I can give you one example for that. A quick example. Let's say that I've taken 3:6. Okay, so here we have numbers 1, 2, 3, 4, 5, 6, so on. Okay, it can go on and on, right? Let me extend the time for you. Okay, now here we see that if we divide both the numbers 3 and 6 by 1, then we can get the same number, which is 3:6, right?
Yep.
So we'll move on to the next number. We will never start with 1 because whenever we divide any number with 1, we are going to get the same numbers, right? So we will move on to the next number, which is 2. Now let us divide both of them by 2. Now here, will 3 get divided by 2?
No.
No. So this is also a failure for us, right? So we'll move to the next number, which is 3. Okay. So what will you do? You will divide both the numbers by 3. So 3 ones are 3 and 3 twos are 6. So the ratio becomes 1:2. Okay. So this is also another way. So the thing that was taking you time here was you can also do it this way. Let us write all the numbers first. 1, 2, 3, 4, 5, 6 and so on. So we will always start with 2. Okay. So let us start by dividing it by 2 first. Let me erase all the other things from here. Okay, so let us divide both the numbers by 2. So 2 4s are 8 and 2 5s are 10. So the ratio becomes 4:5. Okay, pretty simple, right? So once you have got the simplest form, you don't need to move to the next number. You stop here at 2 only. You don't move to 3 and 4 and 5 and so on, right? Okay, so now we know that the numbers actually which are able to divide both the numbers at the same time, 8 and 10 at the same time, is basically called the common factor. So basically here 2 is the common factor for 8 and 10. Okay, so here actually comes, sorry, yes?
I have a question. What if you do 8:16?
Yes, okay, let me write it for you. If we take 8:16, so now we know the tables of 8, right? We can know that it is 1:2. Because both the numbers 8 and 60 have a common factor, which is 8. Okay, so it is very simple for us. The more higher numbers you're going to take, it is more and more simple for you. Why? Because higher numbers have factors, a lot of factors, and we can see the common factors. Now here in both the numbers 8 and 16, we have a common factor, which is 8, because 8 is able to divide 8 and 16 both at the same time. So 8 divided by 8 and 16 divided by 8, it gives 8 ones are 8 and 8 twos are 16. So we get the answer 1:2. Okay, clear? Now I have a pretty nice question for you. Okay, not a question, actually a sort of example. We'll do it together, and that would be the last thing. If you want to continue more, you can tell me. Okay.
Okay.
But I guess this is enough for today, right?
Yeah.
But we'll do that once. Okay, let me know when you're able to see it.
Okay. I can.
Are you able to? Okay, very good. So here, the question is, at the 6th grade school dance, there are 132 boys, 89 girls, and 14 adults. You can take a paper and pen if you want to. Okay, I can also grant you access for writing. Yeah, you can also write on the board.
It's fine. I already wrote it down on my paper.
Okay, fine. So the question is, write the ratio of the number of boys to the number of girls. Can you tell me the answer for that?
It's 139 to 89.
132. Number of boys are 132, okay? Yes. So 132 to 89. Right. Answer is right. Okay. So we know how to write the ratios now. Okay. Moving to the next one. Can you scroll it down?
Can you scroll it down because I can't really scroll down.
I did it for you actually.
Is right now loading.
Okay. Give it some time. It takes time sometimes. Are you able to see it?
It's not scrolling down on my screen.
I've scrolled it down for you actually.
Can you just tell me a question?
Okay, I can tell you the question. The question is to find the ratio of number of boys to the number of adults.
The number of boys to number of adults is 132 to 14.
Very good. It is 132 to 14. Okay? Good. Now we have one more question. In the cafeteria, are you able to see the question? The second question?
No.
I don't know why your screen is not getting scrolled down.
Yeah.
Because it's all in your hands. Your screen will be scrolled down by you only. But it's fine. Oh, good. Good, very good. So the question is, in the cafeteria, 100 milk cartons were put out for breakfast. At the end of the breakfast, 27 remained. So what is the ratio of the number of milk cartons taken to the total number of milk cartons? Can you tell the answer?
Wait. You think?
Okay, you can take time.
63 to
Good.
100.
Good. This is correct. Okay. Now we have last part of the question. I hope you're able to see it.
I can't really see it.
Okay, I can tell you the question. We have to find the ratio of number of milk cartons remaining to the number of milk cartons taken.
27 to 63.
Yes, good. Just make sure that you're able to, let me tell you here, you told me the answer 27 to 63, right?
Yeah.
So can you find a common factor for both of them? Started with 1, 2, and 3. This is the simplest way you can do it.
It's 3.
Okay, good. So with 3, if you divide both of them by 3, you get 9, 2, yes,
9.
21. So can you again divide it with some other number? Is there again some common factor?
Yeah, it's another 3.
It's again 3, yes. So you have to again divide and divide until you get it into the simplest form. So it becomes 3 to 7, right? So is there one more way that you can divide it?
No.
No. So this is actually the simplest form. So you have to move from the complex form to the simplest form till it is not able to get divided further. Okay?
Okay.
So I think this is enough for today, right?
Yeah.
Okay, good. So do you know how to leave the class?
I can't leave while you're presenting, I'm pretty sure.
Do you see on the right corner, top corner, can you see a window with an arrow? It's writing sign out there.